You're listening to DTFHN for April 13th, 2026. I'm your reduced to first principles host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where people who optimize compilers for fun argue about cola recipes. Today's got that tinkerer energy. Everyone elbow deep in something they built because nobody told them to. Let's get into it. Let me make the strongest case against caring about this paper. Mathematics already has perfectly good operators. We have addition, multiplication, exponentiation. They work. They're well understood. Reducing everything to a single binary operation is a parlor trick. Intellectually cute, practically useless. A real engineer needs real tools, not minimalist abstractions. Nobody is going to throw away their scientific calculator for 2 buttons. Now let me explain why that argument completely misses the point. A researcher has shown that a single binary operator, called EML, can generate every elementary function: sine, cosine, logarithms, exponentials, polynomials, all of them. 2 buttons, EML, and the number 1. That's the entire alphabet. Everything else is composition. And the structure underneath is beautiful. Every EML expression maps to a binary tree, and those trees are isomorphic to Catalan numbers. One of the most deeply studied objects in combinatorics. This isn't some ad hoc construction bolted together to prove a point. It fell out of mathematics that's been there all along, waiting to be noticed. The reason the parlor trick objection fails is that it confuses practicality with profundity. The iota combinator, a single operation that generates all of computation, isn't practical either. Nobody writes production code in iota. But understanding that all of computation reduces to a single combinator changed how we think about what computation is. It's the difference between using a tool and understanding the tool's foundation. This is the same move, but for continuous mathematics. One operator, everything else emerges. And here's what matters about where this work lives. It's on ROCm, open access. The paper, the proofs, the construction. Anyone can read it, verify it, extend it. The Hacker News comments already show people stress testing it, finding edge cases in the derivation of -x, running it through language models as a benchmark. That's the open knowledge cycle working exactly as it should. Someone publishes a result, and within hours, a global community is pulling it apart, building on it, pressure testing every claim. One commenter connected EML to how 1-bit stacks are encoded in binary. A single number representing a full stack of zeros and ones. Another drew the line to fractran, Turing complete computation through fraction arithmetic. These aren't idle comparisons. They're people recognizing the same deep pattern, that apparent complexity often compresses into shockingly simple foundations. The tools to explore this are available to anyone with a browser and the will to learn. That's bootstrapism at its most fundamental. Not code, not software, but mathematical knowledge itself. Published openly, built upon freely, belonging to no one, and therefore available to everyone. Now, if open foundations matter in mathematics, they matter just as much in how we build the teams writing the software, and most orgs haven't figured that out yet. One of the top comments on this piece cuts straight to the bone. Someone points out that the Slack example, where the author implies you could rebuild Slack with agents, doesn't even remotely grasp the scale of what Slack actually does. The reliability engineering alone, the observability, the monitoring at scale, and that reaction is worth sitting with, because it reveals exactly the fault line this article is dancing on. The financial framework itself is sound. 8 engineers in Western Europe, €130,000 each, fully loaded, 1 million a year for the team, 4,000 euros every working day. The math on platform teams is genuinely useful. 13 hours per engineer per month to break even. That's the kind of number that should be on a whiteboard in every platform team's workspace. Most engineers have never seen it. Most managers haven't either. And that's the article's real contribution, making the invisible cost visible. But then the author runs the logic forward into LLM territory and something breaks. The claim is that agents producing code at 10 or 50 times the speed of humans changes the entire calculus. Follow that to its logical extreme. If speed is the variable that matters, then the fastest possible engineering organization is one with 0 humans and infinite agents. Every cost center vanishes. Every sprint completes instantly. And you get... What exactly? This is where the craft appreciation matters. Software at scale isn't a typing problem. The commenters who push back on the Slack example aren't being defensive. They're pointing at something the spreadsheet can't capture. The reason Slack works at planetary scale is thousands of decisions made by people who understood failure modes that no agent has encountered yet. Decisions about back pressure, about graceful degradation, about what happens when a data center goes dark during a message storm. One commenter nails it. The only thing that matters is whether people on the team care deeply about the product. That's not a sentimental claim. It's an engineering claim. Systems built by people who care fail differently than systems built by people optimizing a cost function. They fail recoverable. The financial visibility argument is genuinely important. Engineers should know what their time costs. Product managers should make prioritization decisions with real numbers. But the article's pivot from understand your costs to replace your costs with agents confuses the ledger with the thing the ledger measures. The open source world has always understood this intuitively. 1,000 contributors don't outperform a proprietary team because they're cheaper. They outperform because distributed care scales in ways that centralized cost optimization never will. The agents are powerful tools. Use them to amplify that care, not to replace it. So, what happens when one person actually picks up those tools and starts building? Story 3. Let me work with the article content provided. I have enough detail to write this segment. Look at the deploy button. Not a pricing page, not a sales funnel, not a contact us for enterprise. A deploy button, Heroku, render, railway. Pick one, click once. You're running your own social media management platform. That single UI choice tells you everything about what Brightbean Studio actually is. Someone built the equivalent of Sendable or Content Studio. 10 platform integrations, approval workflows, a unified inbox, scheduling calendar, media library, client portal with magic link access. In 3 weeks, using Claude and Codex. And then they put every line of it on GitHub. Let's pull this thread. In 1991, Linus Torvalds posted a free operating system kernel to a Usenet group because he thought it might be useful to someone. The commercial Unix vendors, some, SAP, IBM, had spent decades and billions building proprietary systems with per-seat licensing. They looked at Linux and saw a toy. 33 years later, Linux runs essentially everything. The pattern repeats because it has to. Per-seat licensing is artificial scarcity applied to bits. And bits want to be free. Brightbean connects directly to every platform's first-party API using your own developer credentials. No aggregator middleman. No vendor sitting between you and your data. This is elegant engineering, and it deserves to be named as such. Most social media SaaS tools route your content through their own infrastructure. Partly for convenience, partly because that routing is the lock-in. Your tokens live on their servers. Your publishing history lives in their database. You leave, you lose your audit trail. Brightbeam's architecture rejects that entirely. Your credentials, your infrastructure, your data. The approval workflow supports configurable stages with threaded comments and a full audit trail. Features that SaaS competitors gate behind their $50 a month tier. 3 weeks! That timeline matters because it demonstrates something the SaaS industry would prefer you didn't notice. The moat around these products was never the technology. It was the labor cost of building it. AI-assisted development just drained that moat. When one person with Claude and Codex can replicate a product category in 21 days and release it for free, the $100 monthly subscription starts looking less like a service and more like a toll booth on a road that now has a bypass. The tools exist. The deploy button is right there. That's how open source wins. Not by arguing about licensing philosophy, but by making the free option so complete that paying becomes a choice rather than a requirement. And that same energy is shown up in hardware, where AMD's ROCm stack is quietly making CUDA's grip on GPU, computing a whole lot less inevitable. The fundamental engineering problem with GPU software ecosystems is a chicken and egg situation, so perfectly circular. It would be funny if it weren't worth $500 billion. Developers write CUDA because the hardware is everywhere. The hardware is everywhere because developers write CUDA. Every semester, another generation of grad students learns in CUDA first, ships CUDA code, and the flywheel spins faster. AMD looked at this and essentially said, okay, what if we just stop playing that game entirely? That's the real story buried in this EE Times interview with Anush Alamgovan, AMD's VP of AI software. The Nod.ai acquisition 2.5 years ago wasn't just an acqui-hire. It was a strategic pivot away from the CUDA translation treadmill. The old approach, converting CUDA kernels to HIP kernels, one function call at a time, was a losing proposition. You're always one release behind, always chasing someone else's API surface. The new approach is architectural. Triton OpenAI's open-source GPU programming framework became what Langevin calls the great equalizer. Write a Triton kernel, it runs on AMD or NVIDIA. No translation layer. No compatibility shim. The abstraction moved up, and suddenly the moat looks less like the Grand Canyon and more like a drainage ditch. Run this forward 5 years. ROCm hits a 6-week release cadence, which Langevin says is imminent. The compiler infrastructure, MLI, and Torch MLIR matures to the point where retargeting across hardware types is automatic. Inference customers are already hardware agnostic. They're running VLLM or Erlang. They care about tokens per second, not what logo is on the silicon. The lock-in erodes from the top of the stack downward. Now the comments section tells you where the pain still lives. Consumer GPU support is a mess. The RX 58 can do the math, but ROCm won't talk to it. Laptop GPUs. APU it. Ignored. AMD made a calculated bet to win the data center first and backfill consumer later. That bet might be correct strategically, but it means the hobbyist tinkerer, the person who would evangelize ROCm the way early Linux users evangelized the kernel, is stuck using Vulkan backends as a workaround. You're leaving your grassroots army on the bench. The compiler first approach is the right architecture, though. Instead of building a CUDA-shaped hole and trying to fill it, AMD built a layer that makes the question of CUDA versus ROCm increasingly irrelevant. The best way to defeat a proprietary standard isn't to clone it, it's to make it optional. Moving on. In 1999, a Canadian startup called OpenCola did something deliberately absurd. They published a cola recipe under the GNU General Public License, same license as the Linux kernel, applied to a soft drink. The point wasn't really the soda. It was a demonstration that open source principles could escape the screen and enter the physical world. Most people laughed. The recipe spread anyway. It got translated into dozens of languages. People actually made it. 20-some years later, someone named Blenry is standing in their kitchen with a 1 milliliter syringe, measuring out 0.05 milliliters of lavender oil and publishing the results on GitHub. The lineage is direct. Open Cola begat Cube Cola begat that. And the whole thing is a beautiful case study in what happens when you strip a product down to first principles. What is cola, actually? Forget the mystique, forget the locked vault in Atlanta, forget a century of marketing. Cola is a handful of citrus oils, some spice oils, an emulsifier to keep them suspended in water, citric acid, sweetener, and caramel color. That's it. The secret formula is about 7 essential oils measured in fractions of a milliliter. 2 milliliters of oil flavors, 9 liters of finished drink. The ratio is so extreme, it's almost funny. You are essentially drinking very slightly perfumed sugar water, and the entire global soft drink industry is built on convincing you that this particular arrangement of orange oil and nutmeg oil is worth a trademark war. The real craft is in the emulsion. Gum Arabic. Tree sap, basically. Wraps each oil droplet so it stays dispersed instead of floating to the top. One commenter points out you should buy pre-hydrated gum Arabic because that's where everyone screws up. This is the kind of hard-won practical knowledge that only surfaces when recipes are open. Nobody at Coca-Cola is posting emulsification tips on Mastodon. What catches me is the gaps. Blenry notes there are almost no open recipes for sodas besides cola. Orange soda, cherry soda, almond soda. These are trivially simple flavor profiles, yet nobody's documented them. Cola got reverse engineered because cola had mystique. The boring flavors got ignored precisely because they seemed too simple to bother writing down. Meanwhile, someone in the comments is replicating Club Mate. Someone else is doing kvass from toasted rye bread. Another person used a mass spectrometer to fingerprint actual Coca-Cola. This is how open source wins in any domain. Not by one perfect recipe, but by 1,000 people tweaking ratios, substituting sucralose for cyclamate, dropping the caffeine, adding more citric acid because they like it sour. The kitchen becomes a fort. Every batch is a commit. The recipe improves because anyone can touch it. Moving on. When I was designing internal tooling, I made what felt like a creative decision. Custom keyboard shortcuts, a novel navigation pattern, context menus that broke from convention because I thought convention was limiting. Within a month, every support ticket was some variation of, how do I do the thing I already know how to do? I'd built something technically sound that nobody could use without a tutorial. This essay by John Lober names the exact disease, and the diagnosis is clinical. Consider how buildings work, not the architecture. The interfaces. Every door handle in a commercial building operates on one of about 3 mechanisms. Light switches are at a consistent height. Exit signs use the same color, the same font, the same placement. Governed by code. You don't think about any of this. That's the point. A building you've never entered is a building you already know how to navigate, because the interface layer is shared infrastructure, not individual expression. Windows-era desktop software worked this way. File, edit, view. That menu bar was a building code, the underlined letters showing keyboard shortcuts, the status bar at the bottom, the buttons that looked like buttons and said what they did. These weren't limitations on creativity. They were load-bearing walls. You could build anything you wanted above them, but the ground floor was shared, and that sharing is what made the entire ecosystem navigable. The web dissolved the building code. Every site now invents its own door handle, date pickers that reject typed input, submit buttons that look like decorative text, navigation buried behind icons that could mean anything. One commenter nails it. They can't even type a date into a date picker anymore. The machine is rejecting the most direct possible input in favor of some designer's custom interaction. The article traces this to a real architectural cause: desktop frameworks enforced idioms by default. You got the standard menu bar, the standard dialog boxes, the standard keyboard handling because the platform gave them to you. The web gave everyone a blank canvas and said good luck. What's worth noting is that the frameworks that reimpose these conventions, the design systems, the component library, are overwhelmingly open source. The shared infrastructure is being rebuilt, one React component library at a time, by people who understand that consistency isn't a constraint on expression. It's the foundation that makes expression legible. The building code returns when builders choose to adopt it together. Now for something delightfully specific. Someone looked at the macOS doc and thought, I can make this boring, and they were right to. $40. That's what it took to mass convert a Hacker News comment section from mass revolt to mass support. boringBar is a macOS dock replacement. Takes your dock, your menu bar, and your system tray, and collapses them into a single Windows-style taskbar at the top or bottom of your screen. It's clean. It's well executed. The developer clearly understands macOS design language because the thing actually looks native, which is harder than it sounds on Apple's platform. But the real story here isn't the software. It's the pricing pivot that happened in real time, in the comments. The developer launched with a subscription model, $7.99 a year per device, and the response was immediate and unanimous. People who explicitly said they were the target audience, people who wanted this exact tool, walked away. A subscription for a taskbar utility crosses some psychological threshold that even cheap subscriptions for other software don't. There's something about paying rent on your own desktop Chrome that feels fundamentally wrong. The question nobody in the SaaS pricing world wants to sit with is this: at what level of the stack does subscription pricing become an insult? We've somehow normalized subscriptions for everything. But a taskbar, a thing that sits between you and your operating system, that you interact with thousands of times a day without thinking. Asking someone to subscribe to that is like asking them to subscribe to their light switches. And the developer listened. Within the thread, they switched to a perpetual license. $40, 2 devices, 2 years of updates, software keeps working forever after that. The comments flipped. People started buying it on the spot. What's worth pulling out of this is the contrast with the open source alternatives people were listing. Alfred, Raycast, Aerospace, Sketchybar. Free tools you can assemble into roughly the same experience. The developer is competing against that entire ecosystem with a closed-source, paid product. And the only reason anyone's willing to pay is because the integration is seamless and the price respects the relationship. Perpetual license says I'm selling you a tool. Subscription says I'm renting you access to your own workflow. One commenter raised the deeper concern. What happens when the activation servers go down? Your taskbar stops working because a server you don't control went offline. That's the architectural question that matters beyond any pricing model. Who holds the off switch to your desktop? And hey, if controlling your own desktop feels like a lot, next up. Most people can't even juggle one ball. What does it actually mean to learn something? Not to know about it, not to watch a tutorial, not to understand the theory, but to wire your body and mind to do a thing they couldn't do before. This piece on ROCm uses juggling as a lens into skill acquisition, and the core insight is deceptively simple. Most people who fail to juggle 3 balls never actually learn to juggle 1. They skip the foundation. They grab 3 balls because that's what juggling looks like from the outside, and they wonder why everything falls apart. The parallel to engineering is immediate and honestly kind of painful. How many people try to build a distributed system before they understand a single process program? How many jump to Kubernetes before they can deploy a binary to a Linux box? The failure mode isn't lack of talent. It's skipping the 1-ball phase because it feels too basic to bother with. One commenter describes failing to juggle for years until they stood over a bed and just listened to the rhythm of the balls landing. They stopped watching and started beeling. That's the moment where learning actually happens. When you stop performing the skill and start building the circuit. A longtime juggler in the thread confirms this. The 3-ball cascade isn't really about hand-eye coordination. It's about internalizing a timing pattern until your hands know where to be without your eyes tracking every art. This is builder culture at its most fundamental. The juggling community figured this out decades ago. Noisebridge in San Francisco runs a weekly workshop. Juggling with Judy every Saturday, where the teaching method is exactly this. Start with 1 ball, get the throw right, build from there. Open knowledge, shared freely, refined through practice. The most interesting comment might be the person who learned juggle in junior high and can still do it years later without practice. The skill persists because it was built properly, the foundation holds. There's a question worth sitting with here. In a world obsessed with scaling, with doing more, with running 3 things at once, what are the 1-ball skills we're skipping? What foundations are we building on sand because the fundamentals felt too slow? The tools exist. The knowledge is available. The hard part was always the patience to throw 1 ball correctly before reaching for the second. And if you want to see what people look like when they're actually building those foundations, let's check in on the builders themselves. Let me make the case that these Ask Asian threads are useless. Hundreds of comments, most half-baked, nobody following up. A graveyard of weekend projects destined for abandoned GitHub repos. The cynical read is that this is performative building. People announcing intentions to a forum instead of shipping code. And honestly, some of it is exactly that. Now let me tell you why that critique collapses the moment you actually read these threads. Someone built a picture frame, not a startup, a picture frame. Their mother lives alone, and they're reaching the age where that becomes terrifying. So they wrote software that watches for motion in her house and quietly reports back. Still kicking, they called it. No venture funding, no product market fit analysis. Just a person who knows how to code solving the most human problem imaginable. I need to know my mom's okay. Someone else got addicted to doom scrolling, so they built a digital pet that suffers when you pick up your phone. The engineering is almost irrelevant. What matters is the instinct. I have a problem. I have tools. I'm going to build my way out. There's a self-hosted relay tunneling TCP through encrypted WireGuard connections. Open source on GitHub, explicitly positioning against Tailscale's closed model. There's someone designing a Coke-based distributed messaging system from scratch, because ROCm wasn't quite right. There's a hosted CMS that started because someone's wife needed to update her website without learning to code. Every single one of these is a person putting tools where others can reach them. The picture frame code, published, the relay, on GitHub, the CMS, hosted and available. This is what building culture actually looks like, not keynotes, not fundraising announcements, people in rooms solving problems they personally feel, then. And this is the part that matters. Leaving the door open behind them, the source available, the approach documented, the ladder extended. Run this forward, 1,000 builders tinkering on problems they actually care about will always outpace 100 building what a product manager told them to, every time. And sometimes, that tinkering takes you all the way down to the middle, optimizing how processes handle something as fundamental as division. A Hacker News commenter named Ridiculous Fish, who, by the way, wrote the fish show, drops into the thread to point out that this paper missed the state of the art, and the state of the art is his own work. You can't make this up. The paper is about optimizing 32-bit unsigned division by constants on 64-bit machines, which sounds impossibly niche until you realize this operation happens billions of times per second across every compiled program on Earth. When you divide by a constant, compilers don't actually divide. They multiply by a magic number and shift. It's a trick that's been around for decades, and the whole game is making that magic number fit in fewer bits so the CPU can chew through it faster. The new paper shows you can use 32-bit magic numbers instead of 33-bit ones for 32-bit division on 64-bit targets. Reasonable contribution. Except Ridiculous Fish already solved a more general version of this, and Daniel Lemire mentioned it offhandedly in a blog post years ago. The LLVM pull request implementing this is already up, and as commenters note, it works in registers but not in vector operation, which is where you'd really want the savings. Let's pull this thread. Someone in the comments recommends the book Hacker's Delight, which is basically the Bible of bit manipulation tricks. Published, available, every trick in it is a tool anyone can pick up. And that's the pattern here. This entire soap field advances because people publish their magic numbers, their proofs, their compiler patches. The LLVM PR is right there, readable, reviewable. Ridiculous Fish's algorithm is documented and open. This is what progress looks like at the middle level, not patents on arithmetic. People racing to give away the fastest way to divide. This has been your daily tech feed for Hacker News for April 13, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something only you would think to build. We'll see you back here tomorrow.